this video, you are going to learn about the introduction to improper integrals. But before we focus on the improper integrals, let me show you what is a definite integral means, where we have learned in the previous chapter. So a definite integral meaning that we have the finite interval from a to b of fx dx. So let's say a finite number meaning that, for example, you have to find the integration of a function of fx dx from 1 to 10. So this is called as a finite interval where we have value for that interval. Okay, and another one for definite integral is that the function of fx here is continuous. It doesn't have infinite discontinuity at a certain interval. Okay, now, what if this concept is extended to the cases where the first cases is one of the interval here or both of the interval is infinite. Let's say it's from a to infinity of fx dx, or it's from negative infinity to b of fx dx, and another one if both of the intervals are infinite. So it's from negative infinity to infinity fx dx. Or there is another cases where the function of fx is discontinuous at a certain point between the interval of a to b. For example, the function of 1 over x squared dx from the interval 1 up to 10. Okay, for both cases, okay, so this is the cases that we call it as improper integrals. Where the improper integrals, we have two cases. The first cases is where one or both limit have infinite, and then the type 2 cases is the function is discontinuous at a certain point or at the end point of the interval. We will go through for both cases later. Okay, now let us try this example. Determine if the following expressions are improper integrals. So I want you to pause this video and identify if these expressions are improper integrals or not. Then we will discuss the answer. Okay, for A, we have the integration of sine nx dx from 0 up to pi. So here our sine nx is a function that is continuous, and our interval here is a finite number. So this integral is not improper integrals. Okay, now we go to B. We have the integrals from dx over x squared from 1 up to infinity. So the first one is, we can see that we have the infinite value at the interval, at the upper limit interval. So this falls under the case 1, the type 1 of the improper integrals, where one of the interval is infinity. So here it is improper integral. Okay, for C, from the function of the integration of dx over 1 minus x squared from the interval negative infinity to infinity. So this clearly is the case of type 1 of improper integrals where both limits are infinite. And the last one is from negative 2 to 2 dx over x minus 1. So we can see here that the interval here is a finite value. So it is not a type 1 cases, but you have to check the function of these integrals where it is 1 over x minus 1. We know that if our denominator or our below part here, if this one is equals to 0, or we can write it as 1 over 0, it will create an infinite value. So we can see that if x is equals to 1, then we will get infinite value at x equals to 1. So meaning that if we draw this graph, let's say the graph is something like this. So the interval starts from negative 2 to 2, and we know that when x is equals to 1, the value will be infinite. So here the function is discontinuous at x equals to 1. Therefore, this integrals falls under type 2, where the function is discontinuous at x equals to 1. So D is improper integrals.